Hey guys, welcome to this session. In this session, we are going to see Oracle database architecture. Okay. In Oracle database architecture, we are having three parts. We can read completely one architecture only, but we are going to separate this architecture into three parts. One is this processes one. Processes means user process. We call it as a client also, and the server process. Then these two processes and also background processes. All three processes are related topics. We call it as one separate topic. And then we will read as part of this instance, SG and PGA, we will read it. That is memory part. Okay. What is the memory? So processor is one part, memory is one other part, and the third one is storage. It is a original database, guys. Storage is physical storage. We call it as database. And logical storage means memory. We call it as instance. And the processes will help to serve the request, even though I'll tell you in a couple of seconds what exactly mean by the processes. Okay, first we'll read about the memory structure first. Okay, memory and then background processes. These two involved as part of our instance. As a DBA, if somebody will ask you to start the instance, stop the instance, or shut down the database, start up the database, it means we are going to shut down and start up this instance only, not the database. This database is physically files, physical storage files, data files, control file, redo log files, parameter file, password files. All these are physically. Physically means there are two types of, as I said, this is a physical files, it's a logical files. I'll tell you in a database. Okay, if it is a database server, if I talk about the physical files, PHYSICIL, physical files. Physical files means we can view it when the database is up and running or shut it down. This means up, this means down. Even though if your database is down or up, we can able to see these physical files. What are these physical files? CRD. C means control file, R means redo log file, D means data files, and also password file will be there, parameter files will be there, archive logs will be there. So many files. But important files, what we are going to talk about, these are the files in our database. These are all the physical files. Okay, if you want to see it, you can see it when the database is up and running or down as well. And another kind of files which we are having is when the database is up and running only, we can able to see those files. Those files we call it as a logical files. Logical files. Logical files means we can view when the database is up and running. If the database is down, we cannot view these logical files. These all are in a memory level stored. So that's where we talk about Oracle database instance. Oracle database instance, we call it as a memory part. Okay, this is when you start your database, then only we can view it. I'll show you that. Okay, that is one thing. And also
these parameter files, these are also physical files, huh?
exactly. I'll tell you, Khalil.
Sure.
Definitely, I'll go through it, each and everything, whatever I shared here. See, control files I'll show you, redo log files, data files, parameter files, everything I'll show you. Logical files also we will cover it. Okay. After 30 minutes, you can note down your questions. Definitely, I'll go through it one by one. Okay.
Okay.
Okay. Apart from these things, if you are talking about if it is a database, okay, in database we are having one is logical kind of files, another one is physical files. We will see practically also. Apart from this, if I am talking about objects in our database, as part of this DBA course, I am talking about invalid objects, valid objects, so and so objects. Objects is nothing but package, synonym, sequence, procedure, all triggers, index, views, everything we call it as an object. If anything, one object is invalid means it could be a trigger, it could be a package or sequence, synonym, any one of that is got invalid. What we need to do, if it is invalid, that package or object related information we cannot utilize. So what we need to do? We need to make valid. Then only we can use that object. Everything in our database depends on our objects only. Okay. If that object is not valid, we cannot perform our transactions. That is just for your information. It is out of our architecture. That is one thing clear. So let us jump into this logical portion of our database. Okay. As I said, in our database, we are having physical and logical files. I'll show you right away. And also, once again, I'll tell you that in a practical way, where it is. Let me log into the database. So, apart from this, I'll show you important configuration files also in our database. Okay, we are talking, sometimes we are saying Oracle Home. What is this Oracle Home? Okay, this also I'll show you. Oracle underscore SID. We are going to set as part of our Oracle environment. What is this main? And we are going to set the path. Why we need to set this path? These three also very important as part of this architecture. What exactly mean by this Oracle Home and Oracle SID and path? SID is nothing but our, as part of this instance, Oracle instance, this part, right? SGA plus background processes are there, right? Complete this part, memory part, we call it as an instance. For this instance, we name it as SID. Okay, system identity number. Based upon that, we are going to start our database instance or shut it down that. And also we are having this storage, right? Physical storage, CRD files. For this database also, we are naming it as one name. That is, name is called as database name. So SID name is here we are mentioning, database name is mentioning here. So if you want to keep both the names same, that's okay. If you want to keep different, you can keep it. There is no issue. Okay. But our practically in our normal scenarios also, in organizations also, most of the people are keeping your SID and database name is same. If it is a rack, right? Demo DB. DB name is demo DB, SID is demo DB1. Why? Because we are maintaining this instance, multiple instances in our rack, not the database, a single database, multiple instances. That is where we call it as demo DB1, demo DB2, demo DB3, vice versa. Okay, not the vice versa, and so on. Clear. Let me show you this Oracle Home. What is mean by this Oracle? Oracle Home is holding all the softwares, Oracle database software. That software will help us to perform our DBA activities, whatever our database activities, not only DBA. If it is a developer, if they want to create something, if they want to update something, without this software, we cannot do anything. Okay, that's where we need to mention. If I say Oracle underscore Oracle $home, it is showing this path. This path means we have to set this path. Otherwise, this server cannot read where is your Oracle software. That's where we need to mention our Oracle Home. Okay, these are all the files. When you are downloading your software, unzip it, these files will be unzipped. Okay, so many files are there. Okay, just you want to know, this is our Oracle database home. And what about our instance name? Oracle and Oracle underscore SID means this is our instance name, SID name. Okay, SID name. SID name means, here I showed you, right? SGA plus background process, we call it as an instance. This is our SID name. Okay, this is one we have set it up. And I set the path also, echo $path. PATH. Okay, path by default, if you're not mentioning, it will go to user S bin only, or else user local bin location it will go. If you are seeing any libraries are there in your user local bin. Okay, let me go through this. See here, as and when, as part of our Oracle database installation, when you run the root.sh script, that root.sh script will ask you one path where you need to set all your database home, Ora env, Cora env. What this means is, it will store your database home location, whatever we set this here, echo $Oracle home. Okay, that information will be here only. If you set this path means, it will read everything. It will read the SID, it will read the Oracle home, and it will read the bin path of your Oracle home. Inside of our Oracle home, okay, we have one bin path. Here, these are all the tools. If you want to connect SQL plus as is DBA, this SQL plus is a tool that should be there in your bin location. Where it is SQL plus, here it is. If it is not there, we cannot able to set this environment. Okay, we cannot able to see if I am trying to connect with SQL plus is DBA. Now I am able to connect it. Okay, database is down. Let me start it up. Another instance, I'll show you without set this path, without setting these environments, we cannot able to connect. I'll show you that. Let's say in LTRA, in home location, we are having bash profile. If I could move this bash profile, and then I'll take a duplicate session from here again. Why? Because it's already set the environment in that path. Now, see here, difference it is. Here it is showing, if I log into this instance, immediately it is showing Oracle user and testDB is my database server name. But here it is showing bash. It means it is not set my environment. Oracle underscore home. It won't show anything. I know that. Oracle underscore SID, nothing. If I try to connect SQL plus as is DBA, SQL plus command not found. It means the environment, the bash profile, it is not set it properly. We have to set this bash. Bash profile is nothing but whatever we are going to query Oracle home, export Oracle SID, export path. I'll show you that as well. Let me move back this one to bash profile, and then I'll show you what exactly this bash profile holds. See here, whatever, instead of if you are doing manually, that is fine. But every time if you are not doing manually, you can keep those exports. Where is your Oracle bash base location? Base location means from this base location, we are mentioning our product, this Oracle home, and also Vara data, original data files location, and also diagnostics like your trace files and alert log files, everything will store from this base location. From this base location. See, I gone through this base location. What are all the files? FRA. If you are enabling the FRA, fast recovery area, that also starting from your base location. Vara data, original data files, CRD files will store it in base location. And audit files will be there from the base location. Diagnostic files will store here. CFG tools, like CFG tools will for installation kind of one. And if you are doing any software level changes, all these log files will store in your CFG files. So that is where the base will start from. It is a basement of your database related. But this one, Oracle home, is your Oracle home location, like software where you have unzipped your software. That is Oracle home. SID means what is your database related instance from where you are going to start. This instance will read the data and update the data, insert the data through this instance to this database. That is the instance. Okay, I have shown you completely the architecture physically. And one more thing is, if the database is down or up, logical files, how we are going to see it, sysdba. Now my database is up and running. Select name, comma, open underscore mode from $database. Database is up and running. Select start from dba underscore data underscore files. To view your data files, we can use dba underscore data underscore files view. By using this view, we can able to see our data files, where our data files are exist. See, now the database is up and running. Read write mode means it is open mode. I can able to see these files. Physically, these files are existing in this location. So if my database is down also, I can able to see these files physically, right? Control file is there, temp files, redo log files, system files, sysocs, undo, user, everything is there. Even parameter file also will be there in your database, Oracle home DBS location. Show parameter SGA. This is my one of the parameter file, but if I want to see this memory from the physical file only, I can able to see it. And also the memory assignments and all, we have to do it on logically. And when you start your instance, your bed instance will be start. How we are going to see it is, this is our instance. Also our SMON background process. this S1 background process is up and running. If the instance is down, we cannot able to see the status of this your background process. Not only S1, if you want to see the P1 background process, this P1 background process also we are not able to see it if it is down. That is where the logical portion comes into the picture. When the database is up and running only, we can able to see this background processes and the memory structure also. This memory, how much memory we have assigned and okay, how much memory it is there. And physical files, as I showed you, if the database is down also, we can able to see these physical files. Why? Because we can see it, even if it is up and running, we can use select query. And then we can view it, the sizes and all. If it is down, we can view OS level command, ls-ltr, and then du-sh commands. We can identify the size also. Okay. That is where we call it as a physical file. CRD files are the physical files. Okay. Then we can go one by one individually. So first we'll go through SGA and then we'll go through the database. SGA plus background processes. In our SGA, we are having, I'll show it here. In our SGA, we are having three important. We have, multiple components are there. Okay. But we are going through only three important components. Those are database buffer cache, redo-log buffer cache, and shared pool. Inside of your shared pool, you are having library cache and data dictionary cache. Okay. SGA part, we are going to read it. So in this is an SGA. Inside of this SGA, we are dividing this as three parts. Okay, this is redo-log buffer, database, DB means database, buffer cache, DBBC, and it is a shared pool, SP. It's shared pool library cache, data dictionary, DDC, data dictionary cache, or data dictionary view. Okay. First, we are going to learn about this one. What is meant by the shared pool? Shared pool is a part of your SGA, system global area. System global area means it is going to assign your memory as and when your instance is started. This memory utilized and serves the user requests. Okay, this is a memory component, inside of your SGA component. SGA portion, system global area portion. You are having multiple components. One is shared pool. Shared pool, inside of the shared pool, it holds library cache. Library cache is nothing but it will holds all the parsing related. Library cache will do your database related parsing and also execution plans. Everything will be done from this library cache. As and when any user process, this user process requests one information from your database, from this database. Okay, what will happen? This is a user process. This is a server process. User process sends a valid SQL statement, valid SQL VSS, valid SQL statement, VSS. This server process takes that statement and it will connect to your SGA. Inside of your SGA, it is going to touch up with shared pool. From the shared pool, it is going to touch with the library cache. Here, the query related object, query related information is there or not, it will look into it. The object is there or not. How this will get to know object related? That object related information or base table information will store in your data dictionary cache. So data dictionary cache holds all the base table informations or metadata. Metadata means data about data, called as metadata. Suppose user selected select star from EMP. Okay, EMP, employee related information user is needed. This EMP object exists in your database system or not, it will check here. How this data dictionary cache will hold all this object information? This will read this information from the system table space. Okay, from the system table space, it will loaded all the objects to data dictionary cache inside your SGA memory. Okay, then it will compare the employee object is there or not. Library cache will ask, then it will say to library cache, if it is exist, yes, the object is exist. Then the library cache portion, here it is happening parsing. Okay, parsing also two types, soft parse, hard parse. Soft parse means the query is going to execute second time. For every query which is coming to your SGA or memory, it is going through the hard parse only. Hard parse means the query needs execution plan. This execution plan is given by the Oracle brain that will invoke, okay, first time every query. For that query, also we call it as OCR calls, Oracle calls, Oracle interface calls are OCR. Oracle calls, we call it, done in your library cache. Simple thing. Each and every query, somebody needs to help them to get the information from the database. There is a process inside of that Oracle itself, that is a Oracle brain. Oracle brain will create your best execution plan. 1 to 15 execution plans, it will select it and it will give to that query. According to that query, one of the in between 1 to 15, that will create one plan, and that plan will carry on. And the execution plan will go to this database buffer cache. It won't touch redo log buffers. Okay. The redo log buffers are, if any inside DML operations or DDL operations are performed, then that related current transactions will come in next few seconds. Okay. The execution plan will connect to database buffer cache. If the data is there or not, it will check into here. And then if it is not there, the server process will connect to your database and it will connect to the data files. This from here, it will fetch the information and put it into your database buffer cache. From this database buffer cache, the output will come into library cache. From this library cache, the server process will update that output to user session. This is the way the query will be move on. If the execution plan is not good, the execution plan, whichever it is generated here in Oracle brain, it is not good, the query will take time. Okay, we will get the performance issues. That is where we need to focusing on, as part of our performance tuning, we have to see it, what kind of execution plan the query is having. Okay, and what exactly the query is doing, what kind of access that is taking full table scan or index scan or other hints or anything is there, unnecessary hints, unnecessary index also troubleshooting, give you the trouble of the query. Okay, that is a performance related thing. Okay. That is where the important, I said, right, 1 to 15 execution plans, any one of that will be there. If you want to change the plan also, we can change it. Okay, we can create the plan, best plan also we can create, and we can attach that to that query to improve the query output or the performance. Okay, this is the flow, guys. So database buffer cache is holding the dirty blocks, means used blocks, modified blocks, and ready to free blocks. We are having 3 different kinds of blocks. If initially we are having free blocks. Free blocks means ready to use. Any information which is coming to this database buffer cache, it will take it, and then it will go to current. This is called as current one. The current one will write it, and from here it will write. This one will be invoke. DB writer will invoke, and it will, if it is required, it will update it. Another one is modified blocks or dirty blocks. Modified blocks is nothing but if you are going to update some queries, the updated information, post image information will be stored here, and the updated one will stored in your data files. The post image will go to your undo table spaces. That also written by the DB writer only. DB writer, undo table space. Okay. This action, this activity is also performed by the DB writer. This activity also, DB writer will write the data. That's it. It won't read the data. Read the data will be done by the server process itself from your database. And what about the redo log buffer cache? Redo log buffer cache, each and every transaction which is coming to your database, okay, that will write it here. Continuously, it will write it here. Database redo log buffer cache. From here, each and every transaction will read by the log writer every 3 seconds. I'll tell you as part of the background process when it is invoked and when it is written. And it will write into your redo log groups. Once the group is filled, log switch will be occurred. Another group will be. Once this group is filled, it will log switch occur and it will write it here. This portion is done by the log writer, and CKPT will be there. I'll go through it as part of our background processes. Okay, this is the importance of your SGA, system global area. Okay, whatever the database buffer cache is there, right? Those buffer cache information will write it in your data files. And also this DB writer, right? It is showing one more arrow to redo log buffers. Whatever the committed transactions inside your redo log buffer also. Okay, committed transactions, those will return taken by the DB writer, and then it will write your data files. Okay, that is one thing. And also continuously the redo log buffer cache, whatever the current transactions coming through this redo log buffer cache, even it is a committed or uncommitted, those will return to your online redo log files, that activity performed by your log writer. Okay, archiver is the optional background process that is we will talk about later. And here in shared pool, we are having library cache and data dictionary cache. This concludes our SGA part. And also in our Oracle database instance, we are having important background processes. What are the main background processes? We are having SMON, PMON, DB writer, log writer, checkpoint. These 5 are the important. Archiver, recovery, or echo, other are optional background processes. We are having n number of background processes in our database. Those are optional. But these 5, SMON, PMON, DB writer, checkpoint, log writer are important background processes. What this SMON background process will do? This is a system monitor background processes. System monitor background process will take care of complete other background processes or whatever the background processes is there. If anything is failed, the system SMON will invoke and then it will do the activity, whatever the activity and system level it is required, and that will perform that. It means mainly the SMON will take care of the instance crash recovery, ICR. Okay, ICR will done by the BG, background processes. Background processes are, we are talking about SMON. It will perform ICR, in instance crash recovery. If any instance is crashed abruptly, then SMON will invoke and then it will do the 2 functionalities, that is roll backward and roll forward. Roll backward is done by if any uncommitted transactions or partially committed transactions, it will do roll backward. And if any committed transactions is there at the time of instance failure or abruptly down, the roll forward committed transactions is there, that will be only committed transactions, fully committed transactions. Those will roll forward. After the instance recovery is done, this partially committed or not committed transactions, we will not get it. Why? Because if it is mismatching the user data and also it won't give the complete information, that will be confusing the users. That is where this roll backward will help to give the clear-cut information, only committed information. Roll forward will help us to save if any committed transactions in the instance. Those will help this SMON background process. That activity done by this SMON background processes. Okay, it will monitor all the data files. SMON will monitor all the data files and the table spaces. If any committed transactions is there or other information is there at the time of instance crash. Okay, that is only one importance of your SMON. Another one is PMON. PMON is for, an abbreviation for SMON is system monitor. It will monitor your system. It is a process monitor. PMON means process monitor. This process monitor will do that. Whatever the user logins, user level, user session level, it will check. If user session is there, if user is not doing any kind of actions, certain time of time, if the session is locked or the session is blocked, that kind of sessions, it will be killed and it will help to other users to use that session. Each session is going to use the certain kind of memory. That memory should be released. Locks, we call it as a locks. If any one of that user session is locked certain kind of time, that locks will be released by this PMON. If it is not released, the memory will be locked. That will not useful for other users. That activity is done by the PMON. And another example is if 2 users are trying to access one object or one table space in your database, employee table space, user 1 and user 2. If both are trying to access it, they can able to get the information. But if the user 1 is want to update some DML operations, any updates or any deletion kind of portions, whatever the update he did, this user 1 updated salary from 200 to 300. 200 employees. This whereas and when this user 2 is trying to access this salary part of this employee, he is to get the 200 output only, but he is expecting 300 output. Why? Because the employee which is there, this after he got some hike and all, the hike should be available. But until unless this hike amount, whatever it is there, 300, that should be updated in this employee object, and then you need to do the commit. If this employee information he's committed, but he's not do the insert the commit option. It won't store, it won't give to that information to this user. Even this user is trying to update at that time. That will not help. Already operation in progress. Already the transaction updation is in progress. Any one of that user is trying to update something, other users cannot able to do all remaining DML operations parallelly. What the PMAN will do it will check this user session level, what exactly the session is doing. If session is active, it will wait. The session is inactive, immediately that information, the session information, it will be cleared. Then only this user can able to update this salary to 200 to 300. So that kind of updates are that kind of information or activity performed by your process monitor. Okay. Any user session is abnormal or hanged, that user sessions will killed by this PMAN. PMAN will kill that hanged sessions and all. Okay. Everything. This also, each and every background process are using the memory, whichever we assign to this PGA, Program Global Area, one of the memory component. This PGA will help to the users or the system for sorting operations. Any order by where class, anything which you used in your select queries, this PGA memory will be used. Apart from that, this PGA will gives the memory to your background processes. Whatever the memory on your PGA, those will used by the background processes, and also server process also will use each transaction, each server process where PGA will take certain kind of memory. Once the process, the request is completed, those server process will release the memory to PGA. Okay, PGA is for Program Global Area for sorting purpose. That is one thing. And also we are having another important background processes are DB writer, log writer, LGWR. I'll write CKPT here. Checkpoint. What this DB writer will do? What are all the committed transactions identified? What are all the committed transactions are identified in your database buffer cache or Redolog files? Those committed transactions will return to these data files. How this DB writer will knows those committed transactions? This checkpointer will invoke. Okay, this checkpointer will invoke this DB writer. Hey DB writer, I found some of the committed transactions in the database level, in your DB buffer cache level. So please write those transactions to your data files. Then DB writer will invoke and then it will write it. And also, if any transactions are occurred here in the Redolog buffer cache, the log writer will invoke, and then those Redolog transactions will return to this Redolog files. Whenever the log buffer contains a copy of or modified records are obtained, immediately that log, whatever the modified blocks or modified transactions are obtained, then log writer will write it here. Also, if log buffer is filled 1/3 or every 3 seconds, the log writer will invoke and then it will write all the transactions to online redo logs. That is one thing. Okay. Whenever the log switches happen here, the committed transactions which are there in our log group 1, those log groups also the checkpointer will invoke and log switches happen. Then the committed transactions, if anything is missed from here, DB writer will read that information from this log file group also. And then those committed transactions will return your data files also. That will also DB writer will perform. Okay, checkpointer one, if you want to talk about specifically, whenever any transactions, committed transactions or committed statement issued in your database, okay, checkpointer background process will invoke and then it will intimate the DB writer to update the database buffer, the information, whatever the buffer information is there, please update this buffer information into your data files. It will invoke it. Then it will update, DB writer will update that information into your corresponding data files. And also it will update the log buffer information into your log files. Whatever the checkpoints, this information is there, no, that log buffer information also, it will invoke DB writer and it will update it. And it will generate each committed transactions related to checkpoints. check numbers, we call it as, or else SCN numbers, we can say check numbers, we call it as. When that check numbers or SCN numbers will help us, if any instances recovery is required, those SCN numbers will return in your control files also. Each transaction control files or check numbers will be useful for FRA, fast recovery, if it is required for your database. We can use checkpoint numbers. For every second, the checkpoint will invoke, and that checkpoint number will stored in your control files, headers, and all. Those will help us to restore your database or recover your database as and when it is required. Where the check numbers will be stored, that in your control files. Okay, that check numbers are very, very important. That is the importance of your background processes, SMON and PMON, DB writer, checkpointer, and log writers. And we talk about the server processes, right? In our server process, it will holds the information related to all the user related requests. Whatever the user is requested, one process needs to be there on our server process is your database process, one of the database process. What it does is, when the user is requested any one of that information, that user request will be fulfilled by the server process. Server process will take or listen those requests from the listener. From here in this diagram, user is requested something, then the listener process will take it on the database side. Server process is on database server, database level process. It will take the PGA memory, like from the PGA, it will take the memory. Okay, user global area will be there in your PGA. That memory will assign to your each and every user process. That process will be taken care by the server process. Once the listener is listen the request, and server process take the request from the listener, and it will assigning to the threads. In our server process also, we are having two types of or three types of processes again in the server process. One is a listener will be taking care of the requests which are coming from the user process. It will listen, and the server process will take it, and it will take the dispatchers. We call it as a dispatcher, and dispatcher threads will be there. From the listener to dispatcher, and the dispatcher to dispatcher thread. That dispatcher threads will read the data from the data files, and it will give it back to the dispatcher process. That dispatcher process will send the output or required information or requested information to user process. Okay, listener is the first server process. It will accept the request. It is the first server process, and it will forward the request to dispatcher. And the dispatcher is the main server process that accept the request from the listener, and it will gives the dispatcher will identify that where the dispatcher threads are there. That dispatcher will gives the request to dispatcher threads. Dispatcher threads will take the request from the dispatcher, and it will serve the request. Okay, there also we can talk about two types of dispatcher threads. One is dedicated, another one is server. Dedicated means if you are small environment, small organizations you are using, each process is having one dedicated thread will be there. Dispatcher threads will be there. But in a huge environment, terabytes of data is there, n number of transactions is there. At that time, you are using shared server process. The shared server process will serve multiple requests, multiple threads at a time. That is different. Just for theoretical part, we are going to learn about that. Otherwise, complete all this listener, dispatcher threads are in a single way. We call it as a server processes. Complete all these processes, we call it as a server process. For user request, it means user means it's a client from where we are trying to access this database server. This server from where I'm trying to access from my machine. This is my client machine. We can talk about the client machine. Put is one client machine. Each and every SQL developer from where we are trying, from SQL developer, I'm trying to get connected to the database and get the information. Those processes we call it as a user process or client process. Okay, the client processes are request the information whatever they want. That request will fulfilled by the server process. How the server process will go? It will divide it into three parts. One is the listener, dispatcher threads. Listener will request whatever the request coming from the client. Listener will listen, and it will give to the dispatcher. Dispatcher will listen the request from the listener, and then it will give to dispatcher threads. The threads will collect the information and will give it back to your user session. Okay, that will concludes our this instance portion and our memory or parameter, user sessions, user process information. And we talk about the database. This is our physical files. in our database. Data files are nothing but the original data. All the committed data of your organization related things will stored in your data files. Guys, this data file size is huge. It is depends on your environment usage device that will keep on increasing the data. We have to keep on add the data files. Okay, data files are the physical files. Logical file name is table space. Okay, data files we call it as a physical files. As and when you are creating your database, you will get 5 data files. 5 mandatory, we talk about the table spaces, right? Even data files, so mandatory table spaces are 5. System, sysops, undo, user, temp. Physical, logical. Physical name we call it as all these files. Physical name is data files. Data files. Logical name is table space. Physically, the files we call it as system data file, sysops data file, undo data file, user data file, temp data file. Not the temp data file, it is a temp file. Not the data file, it is a temp file. Okay, the system data file, physically name it as data files, but in a logical manner, if you want to call system table space, sysops table space, undo table space, user table space, temp table space, these 5 are the important table spaces or data files as part of our database configuration or installation. This system table space or data file holds all the base table informations. All the base table information will hold in your system table space. The sysops will it coming to the picture in 10G onwards. Before 10G, we don't have a sysops table space. It will reduce the burden on your system table space, and some of the base tables information and other objects related information will stored in your sysops table space. It will improve your performance on your database when you have introduced the sysops table space into the database. Undo table space will hold all the post image information. Post image means employee salary is 100. If you want to update to 200, this old information will stored in your undo table space. Original information stored in your user table space. Okay, this is user table spaces are the original data, all the committed information. This is important. As and when you are going to take a backup means you can take all these 4 table spaces backup. If the table space is filled up, we need to add a data files. Okay, physically one data file keep on increasing. It will keep on growth. For these 2 system and sysops table space, don't use for your user related information. It should be maintained by only base table informations only. It is Oracle strictly recommended, don't use your system and sysops table space for user related information. Use your user data file or table space for user related information storage. If it is not sufficient, you can create one more table space, custom table spaces, n number of custom table spaces. You can use these table spaces for each user requirement, each application requirements, but don't use this system and sysops table spaces. These are designed for your base table metadata information or base table information maintenance purpose. Okay, all are crucial, guys. Without any one of these table space, we cannot start our database. We cannot open our database. Okay, that is the importance of our data files. Apart from these data files, we are having another 2. This is a data files we talk about. Another one is control file. Okay, and data files, I'll tell you later on. Data files are sized in GBs and TBs. But in control files are the crucial files in your database, heart of your database, I can say. Whatever the information which is there in your control file, if the control file is not there, you cannot able to start or you cannot able to mount your database. Control file will store all the crucial information, that is DB name. And when the database is created, DB creation date. Okay, where is your data files located? Where is your log files located? All these informations will maintained by the control file. Control file, Oracle recommends you can use multiplex of your control file. Multiplex means we can store multiple locations. U01, you can store one control file or main file. U02 mount point, you can store another. U03, you can store another copy of another copy of. These two are the copies. This is one the main control file. So multiplexing means copy of your original data files into multiple locations. That is multiplexing. Okay, why? Because if anything goes wrong or somebody has been unintentionally deleted this control file, we can use these to any one of these file, and then we can restart our database or restore our database. That's where we have to maintain multiplex. The control file extension is .ctl, and it will sizing portion. It could be an in MBs, not in MBs, KBs and MBs only. It won't grow more than MBs. Very less size. Next one is redo logs. Redo logs is your current transactions. Whatever the current transactions coming to your database, those transactions will retain your redo logs. These redo logs will help you to recover your, as and when recovery is needed, we can use these redo log files, and then we can store or recover our database. Only recovery purpose we are using. The extension for this redo logs is .log. .log is extension for your redo log files naming convention. These log files will maintain by MBs and GBs size. It won't grow in TBs. It will be on GBs, 500 GB, 100 GB, 200 GB. In that way, it will be there. The small organizations, they can use 500 MB size of each group. They will maintain 500 MB. Okay, each group is required 2 members. If it is a group is there, it required 2 members. 1 member is filled up, then it is going to one. Otherwise, same way we can maintain 3 groups members. If you want to divide the members, it will maintain 3. Each group is required 2 members. And data files are original data files. Extension is .dbf. Original data will be stored in your data file. CRD means data files, and the size is in GBs and TBs and so on. Terabytes, petabytes, and use on, like as part of your database, they are day by day it is growing, right? In GBs to TBs, terabytes, and then exabyte, gigabytes, everything. It is keep on growing. So data files are original data files. These 3 are the very, very important. If with any one of the files is not there, you cannot able to open your database. It's very, very important. And one more note, if you want to read these files, whatever the information is there, you have to have used the select query. Don't use cat command, don't use vi command to edit these files. If you are trying to edit, that will be corrupted. Don't try. That's where, right, database level we are having security. All the data will be encrypted. If you want to read it, you have to decrypt. Decrypt means by using the select query, we can read it. Otherwise, there is no security, right? That's where don't try to use the cat or vi or other options to edit the physical data files. You can try to read the data from the data files using select query only. That is what important. Another files we talk about parameter files. Parameter files. Parameter files holds all the crucial information in your database configuration. How we are going to design our database. What are all the important parameters we are having? These parameter files we can maintain in 2 ways. One is P file, physical parameter file, and SP file, server parameter file. This file we can able to read it. Okay, the location is these 2 files are Oracle Home DBS location. Okay, Oracle Home DBS location, both the files. This file we can able to read it by using the cat command. If we are using parameter file in our database, if you want to modify any one of that parameter inside of this parameter file, we have to bounce our database. Means you have updated the parameter file and then you have to shut it down the DB and start up. It means bounce. Bounce means shut down, start up. That called as a bounce. Okay. We have to do this activity. Otherwise, this whatever the change we did, right, that will not impact, that will not affect. And server parameter file. Server parameter file or SP file we call it as, we cannot able to read this file. If you want to try to cat it, it will be corrupted. Don't use the cat and all to read this file. If you want to read this file, you have to convert or create this SP file to P file. Create P file from SP file. Create P file from SP file. And then you can read this P file. Why? Because whatever the data is there, you are trying to create it to P file and then you can read it. Don't try to read it. It won't, it is not readable format. Okay, and then by using, if you are using P file or SP, which file I want to use, if you have a doubts, right? Better you can go with SP file. If here SP file, we are having some advantages. If you want to modify certain kind of parameters, you can do it online without database shut it down and startup. Those parameter values will be updated using the scope equal to options, scope equal to both, scope equal to SP file. Those options we can use it, and then we can maintain. There is no, I mean, downtime will be very less. Some of the parameters is there we need to use, definitely bounds is required. And also by using this SP file, we can improve the performance of our database. Okay, reading the files and all, compared to the P file, SP file will improve your database performance. Yep, that is our parameter file. We gone through it, that's fine. And one more is password file. Password file also very important, as if remotely any one of that user wants to come to connect to your database, and if they want to perform admin kind of accesses, okay, this is a SP file. Location, as I said, it is in Oracle home DBS location. Init sid.ora is the P file. Any one of that file only we are going to use. We will not use both the files at a time. If you want to see which file we used, show parameter SP file. It will show you the directory and the path also. We are using SP file in our database. We are not using P file. Okay. By using the SP file, we have started up and set it down. That's okay, right? And password file I want to show you, right? Oracle LSF NTRA. Where is the password file? This is the password file. The same location. We are having Ora pwd.sid name. This password file will help remotely somebody connected and trying to access, perform the admin kind of access. Without this password file, they cannot perform admin kind of normal activities. They can do it, but admin kind of access, if you want to do, they cannot do that. This password will help them. As part of that clones and all, we are copying this password file and the parameter files to target instance. There we are going to use Harman, and then we are restoring the database, admin kind of access, right? So that activities we require a password file. Yeah, guys, that concludes our architecture part. Yeah.